Hi, students. Continuing on with our discussion of separable differential equations, we're now going to look at particular solutions. So this situation that we're setting up is there's scientists looking at a number of sea lions, and they notice that the rate of change of population is given by this formula, so it's proportional to the number of sea lions. And at time zero, there's 500 sea lions. So if I think about what's happening to my derivative equation, well, if I first plug in 500, I'm going to get a positive value. That's a pretty large value. So my population is increasing quickly at the beginning. But then it's going to slow because as the number of sea lions increases, this value is going to get smaller and smaller. So then it slows. And then it stops growing when the number of sea lions is 800, because that's when ds dt is going to be 0. So now it says write but don't solve an integral expression. So I want an integral that gives amount of sea lions, so number of sea lions after x years. So sea lions after x years is going to be the integral from 0 to x. And so I know it's starting at 0 because it says after x years, so it didn't say between some amount of years. Excuse me. After x years, and then I'm going to put in my function of, well, I don't know the function. So I'm going to say 2/5 800 minus s dt. So s is some function of t that I don't quite know what it is because I would need to separate my variables. So let's see if we can do that. So ds dt is 2/5 times 800 minus s. 800 minus s. I want the s's all together. So I'm going to move this whole term over to the other side and say 1 over 800 minus s is equal, ds is equal to 2/5 dt. And now I'm going to integrate both sides. This is going to be a u substitution. My u is going to be 800 minus s. My du will be -1 ds. So I'll get integral -1 over u du, which is negative ln absolute value of u, equals 2/5 t plus c. Well, let's go back in and fill in what our u was. We'll have negative ln of 800 minus s equals 2/5 t plus c. And now I know that my initial condition was time 0. Sea lions is 500, so I can plug that in. Negative ln of 300 is 2/5 times 0 plus c. So that means my c value is negative ln of 300. And now I can isolate my s. So we're going to have negative ln of 800 minus s equals 2/5 t minus ln of 300. Well, I can get rid of this negative, and that would be nice because I don't like to have that negative there, equals negative 2/5 t plus ln of 300. And now I'm going to take e on both sides. So I need this quantity to be positive if I'm going to have, output of ln can be positive or negative. I need this quantity to be positive. So it's only going to be for number of sea lions less than or equal to 800 is where it will be valid. If sea lions is greater than 800, well, we already said that it stops, the population stops growing at 800. So that's what we're indicating here. So now I'm going to take e to both sides. So 800 minus s equals e to the negative 2/5 t plus ln of 300. And then I want my s by itself. So s is going to be 800 minus e to the negative 2/5 t plus, that is still up in the exponent, plus ln of 300. So how many possible equations are there for the population of sea lions at Elliott Bay? Well, okay, I restricted us already. But really, if I'm just going to talk about algebra, then when I originally took my ln here, I would have said all the way back up here, I had my absolute value of u, and then I stopped writing it. But if I kept writing it, then I would have had absolute value here, absolute value here, absolute value here, here. And then on this side, once I take my e to the other side, this now would have become plus minus. But that's not reasonable. For my number of sea lions in Elliott Bay, only the positive value is reasonable. So I need to restrict this to say that number of sea lions is greater than 0. And over here, we talked about how they're going to go from, as long as they're less than 800, my equation will still hold. All right, so that's an example of using a particular solution. You've got a bunch more down here. So some of these are just algebra, so then you can have multiple solutions. And we'll look some more at situations like this, more real-world situations in your APC. As always, keep putting your questions in the question document or emailing them to us or coming to office hours. We are happy to help you.